In this video, we're going to take a look at calculating the area of a parallelogram and some problem-solving strategies that'll enable us to tackle more difficult area questions. So looking at the question, it's telling us it's a parallelogram that's drawn inside of a rectangle. That's important. Start thinking about the properties of each shape as you read. Using the measurements given, find the fraction in terms of A of the rectangle's area that is taken up by a parallelogram. Okay, so there's a few things that we actually need to do to be able to answer this first part. So they want us to get the fraction, so our answer should be written as a fraction of the rectangle's area. So I need to find the rectangle's area that is taken up by the parallelogram. So I'm also looking up the parallelogram's area. So I'm going to start out with finding the rectangle's area because that's something I know how to do from junior cert, maybe even from primary school. So rectangle area, then, we know that the formula for the area of the rectangle is the length times the width. If I look at our rectangle here, my width is going to be AX plus 2x. It's both of those together. So AX plus 2x is my width, or my length, whichever you want to use it as. AX plus 2x is what we're putting in for our length then. And for our width then, we're going to use 2x. So I'm going to multiply those two things together and use our algebra skills to simplify it as much as possible. So if I multiply those two things together, I'm going to get AX by 2x, which gives me 2AX squared, and I'm going to get 2x by 2x, which is plus 4x squared. So that gives me the area of the rectangle. So I've got marks in the bag straight away if this was an exam paper question. The second thing I'm going to calculate is the area of the parallelogram. So we're now trying to think, right, what's the formula for the area of a parallelogram? And it's actually in our log table, so you don't need to remember it. The area of a parallelogram is A multiplied by H. Now A refers to the base length of the parallelogram. So this length here is going to be our A. And then our height is in reference to the perpendicular height. So if I was to go straight up here, and that height, if we look, that corresponds to this side. It's the same as the 2x. So I actually know that that's 2x. It's the height of the rectangle overall. So I'm then going to have, instead of h then, I'm going to have 2x, and instead of a, I'm going to have ax. Again, I'm going to multiply that out, and I'm going to get ax by 2x, which is going to be 2ax squared. And that's our area for our parallelogram. Now, there's two parts of the question done. I have to go back to that third part, which was to find the fraction. So the bigger shape is the rectangle. So that's what I'm going to be expressing this as a fraction of. So on the bottom of our fraction, we're going to have the rectangle's area. And I'm comparing that to, I'm trying to get the parallelogram. So comparing it to the parallelogram's area. So I'm putting the parallelogram's area all over the rectangle. Parallelogram was 2ax squared, rectangle 2ax squared all over 4x squared, or plus 4x squared. So there we go. So 2ax squared all over 2ax squared plus 4x squared. Okay, we're not quite finished yet, because when I'm looking at that, I can see some common factors. What I can do is I can divide through top and bottom first by x squared, because it's common to every piece of the puzzle here. So I'm going to divide the top by x squared, and I get 2a. I'm going to divide the bottom by x squared, and I'm going to get 2a plus 4. Looking at that again, I can see that there's a common factor again to all of them. 2a and 4 can all be divided by 2. And if I do that, then dividing the fraction top and bottom by 2, I'm going to have 2a plus, or sorry, I'm going to have a plus 4 on the bottom. So a all over a plus 2. And that there is the first part of the question. Part I, it says the fraction in terms of a. So there it is, it's a fraction, and it's all in terms of a. No x's involved, just a. Now, part 2 of the question says, find the value of a required so that the area of the parallelogram is 4/5 the area of the rectangle. Right. If the parallelogram is 4/5 of the area of the rectangle, that means that this area in here is 4/5 this area. We just found out that the ratio of the two of them, or the fraction for any rectangle to parallelogram where the side length of the parallelogram is ax, that would work out to be a all over a plus 2. We actually now know that in our scenario that this fraction works out to be 4/5. So I can actually take that and I can let it equal to 4/5. So I'm going to have that is equal to 4/5. And then this is going back to our algebra. Multiply up by 5 on this side, I get 5a is equal to 4 by a plus 2. And if I tidy that up even more, I'm going to get 5a is equal to 4a plus 8. If I bring this over or subtract 4a from both sides, I'm left with a is equal to 8. And that's our final answer. So it was all about connecting what did we just do with that 4/5. How are they connected?